Hello, I'm Kathy Mathews. I'm from the University of Iowa Carver College of Medicine. I'm a professor of pediatrics and neurology. I run our muscular dystrophy clinic and do clinical research in muscular dystrophies. And I'm going to be talking to you today about dystroglycanopathies. So as a way of introducing the topic, all of these patients have a dystroglycanopathy. And I think you can see that there's a very wide range of manifestations. So over the next 2 mini lectures, I hope to give you a better sense of what that range consists of. So what I'm going to be doing today is going over where do the dystroglycanopathies fit into the entire spectrum of muscular dystrophies and muscle diseases overall. I'm a neurologist and we like to be able to classify things. We're going to talk about what are the dystroglycanopathies, what's the definition, what brings all those patients together and puts them into one clinical group. And then in the second mini lecture, we're going to talk more about what can we learn from individual patients about the clinical manifestations of the dystroglycanopathies. So first of all, this is the orientation slide. The myopathies are all diseases of muscle. So all diseases of muscle are not just muscular dystrophies. So as you can see in this Venn diagram, there are congenital myopathies, there are things that are acquired, there are toxic myopathies, things like statins that injure the muscle. There are myopathies, muscle diseases that are the result of systemic diseases. And you can see the other ones. What we're going to be talking about today are the muscular dystrophies. And the muscular dystrophies are a very large group of disorders, so we need to classify them. And there are a number of different classification systems that have been used. The 3 most common are classifying by inheritance, classifying by clinical phenotype, and classifying by pathophysiology or location in the cell. So we'll tell you a little bit about those. Probably the most common form of classification is by genetics. So you can have X-linked muscular dystrophies, and you guys have heard about that. Duchenne and Becker are the most common X-linked muscular dystrophies, although there are others. Autosomal dominant muscular dystrophies, autosomal recessive muscular dystrophies, and that's where the dystroglycanopathies fit, and then mitochondrial diseases. So this system works great if you have somebody who has a family history. Let's say the patient is affected, and their father was affected, and their mother was affected, and they have several aunts and uncles who were affected. You can say that that's an autosomal dominant disease, but that is not the most common situation in the clinic. It is more common that you have an individual who doesn't have a family history. That individual could have an X-linked disease and their X chromosome hasn't been tested. They could have a dominant disease and it's a new mutation. They could have a recessive disease, or they could have a mitochondrial disease and you just don't have enough information in the family. So it's not, we use that information, but it is not a perfect form of classification when we have a patient and we're trying to figure out what they have. So then we go to the clinical categories. So the dystrophinopathies, or Duchenne and Becker muscular dystrophy, are usually viewed as a separate category, although they, strictly speaking, fit into the larger category of limb-girdle muscular dystrophies. The disorders, the dystroglycanopathies, the disorders we're going to be talking about today are limb-girdle and congenital muscular dystrophies. You notice that among the limb-girdle muscular dystrophies, there are more than 30 types. So limb-girdle muscular dystrophy means that there is early weakness of the shoulder girdles and the hips. Congenital muscular dystrophy, I'll talk about a little bit later, means early onset muscular dystrophy. So both of those have a number of types. So once I've made that clinical diagnosis that they have a muscular dystrophy that has weakness of the proximal arms and legs, I'm not done. Or that they have an early onset muscular dystrophy, I'm not done. And then you can see that there are other clinical classifications that we make when we have a patient in front of us based on what their history is and what their exam findings are. So I mentioned that there are a number of different forms of limb-girdle muscular dystrophy. This is taken from a website that categorizes them all, and you can see that this is a lot of different diseases. And I can look at this, and it does not help me at all when I have a patient in front of me, and it gives me a royal headache. So we have to have a way to organize these diseases that helps me when I have a patient in front of me in clinic. So the pathophysiology organization is of some help to that. So this is the group this is one way of organizing them, that there are the disorders of membrane stability and repair, those that are involved in nuclear functions, so transcription, nuclear membrane, organization of the nucleus, and then others that we don't know for sure how they fit. What we're going to be focusing on today, and what I think you've primarily talked about in this course, are those involved in membrane stability and repair, the Dystroglycanopathies. So the way this helps me in clinic is that almost all of these have a very highly elevated CK, and I'll come back to this, and you may have heard about that before. So that helps me to distinguish between those involved in nuclear function, which typically have a normal or near normal CK, and those of the membrane group. Most of that membrane stability group are recessive, either X-linked or autosomal recessive, and there's at least some experimental evidence that maybe you can cause further muscle injury with certain kinds of exercise, so it may help our counseling in clinic. So when we take the three of these different classification systems together and we have a patient in clinic, we can start to, in our minds, tabulate the information that we're given from each of these and come up with a probable diagnosis. So I'm going to focus now on muscular dystrophies due to disorders of membrane stability or repair. And Duchenne muscular dystrophy fits into this category. This is the way I think about it. So when there is a mismatch between injury and repair, either because the muscle cell membrane is weak or because the cell has a defect in the repair mechanism, the CK, or creatine kinase, which is normally primarily found inside the cell, leaks out, calcium and other bad stuff leaks in, and the muscle cell is injured. Over time, this becomes permanent, and you develop permanent weakness. Now, this process, as you know, goes on during normal daily activities for those of us who don't have a defect in injury and repair. So we can always measure some CK in our blood because we walk and we move, and there's this constant balance between injury and repair. But if you have a disease state so that this balance becomes out of balance, then you have progressive muscular weakness, high CK, and one of these muscular dystrophies. So this sort of is a Venn diagram way of recapping what I just said. There are all the myopathies. There's the group of the muscular dystrophies. There are the membrane-related muscular dystrophies, and then what we'll be focusing on for the rest of the lecture, which is the Dystroglycanopathies. So what are Dystroglycanopathies, aside from a very hard word to say that I keep stumbling over? They're a clinically heterogeneous group of muscular dystrophies that result from hypoglycosylation of alpha-dystroglycan. So what is glycosylation? It's a post-translational modification that is required for some proteins to work normally. And I think you're going to hear in much greater detail in a future lecture about glycosylation, so I won't dwell on this topic. There are different types of glycosylation, and what we are talking about today is the connection of a mannose onto alpha-dystroglycan at a serine or threonine residue. This is for pediatric neurologists. This group of glycosylation disorders is very important because there are other diseases that have very different manifestation that have a different kind of glycosylation. So we're talking today about just O-mannosylation of alpha-dystroglycan. So I think you're familiar with this diagram. Muscle cell membrane, and this is again sort of where the diseases that we're talking about today fit into the big picture. Beta-dystroglycan in pink spans the muscle cell membrane and connects to dystrophin. Beta-dystroglycan and alpha-dystroglycan are cleavage products of one gene. Alpha-dystroglycan is hooks to beta-dystroglycan, and in order for alpha-dystroglycan to then connect to the extracellular matrix, it requires heavy glycosylation. So a simple way to think about it it needs a bunch of sugar groups on, or it's not sticky enough to stick to the extracellular matrix, and you lose the stability of the cell membrane. So as you can see from this slide, if you have abnormal glycosylation of alpha-dystroglycan, you get either a congenital muscular dystrophy or a limb-girdle muscular dystrophy. This slide just focuses on alpha and beta dystroglycan, which we're talking about today, again showing that you need the heavily glycosylated alpha-dystroglycan to maintain the linkage between extracellular matrix and dystrophin intracellularly. So if you have decreased glycosylation of alpha-dystroglycan, you disrupt the link between the intracellular proteins and the extracellular matrix. As we've talked about, that results in muscular dystrophy, breakdown of the balance between membrane stability and repair, and it can also, in this case, result in a developmental defect in the brain and a developmental defect in the eye. This does not occur every time, but it can, and we'll talk about that more as we talk about cases. So this is a slide that is an easy way to think about glycosylation, and it's a good sort of introduction. So in the first row here, this is a slide courtesy of Toby Willer, who was a postdoc in Dr. Kevin Campbell's lab. You can think about the different enzymes that are required to glycosylate alpha-dystroglycan as being workers in an assembly line. So if control is where the, let's say that's where alpha-dystroglycan starts, and it's naked alpha-dystroglycan, and then it works its way along the assembly line, and each worker adds a sugar. Those sugars need to be added in the correct order, and they need to be added in the correct amount. And at the end, if you have them all added on correctly, you can see that you have glycosylated alpha-dystroglycan, which links to the extracellular matrix. And Toby has put in here some of the genes that are involved in this process. And some of them we know what they do, some we don't know what they do. In the bottom row, he has drawn a patient who has a mutation in one of these genes. So alpha-dystroglycan starts out and the sugars are being put on properly, but then we have an injured worker. This injured worker is wrapped with bandages, and that enzyme can't work. Therefore, none of the rest of the enzymes have anything to work on, and you get an unglycosylated or hypoglycosylated version of alpha-dystroglycan that can't connect to the extracellular matrix. So each of these enzymes or workers has a very specific task and can only perform one task. We currently know of 18 different workers on that assembly line or genes that are involved in the glycosylation of alpha-dystroglycan. And mutations in each of these have been shown to cause muscular dystrophy. Again, this is not a list that I can quote off the top of my head, nor do we expect any of you to remember it, but it just gives you the sense that this is a very complex process. So I talked about congenital and limb-girdle muscular dystrophies being the result of abnormalities of glycosylation of alpha-dystroglycan. So I wanted to talk a little bit more before I go on to cases about what exactly these are. So in the top row there, you can see, regardless of what the disease is, what is a congenital muscular dystrophy. So a congenital muscular dystrophy has onset of weakness, and there is no generally agreed upon definition. So some people have said before 6 months, others have said before age 2, others have said before walking. So somewhere in the first 2 years of life, you have onset of clinically detectable weakness. There are a lot of different kinds of congenital muscular dystrophy. And then weakness that starts after that is with proximal muscle weakness, hip girdle or limb girdle, is called limb girdle muscular dystrophy. And in general, the congenital muscular dystrophies are more severe than the limb girdle muscular dystrophies, and the limb girdle muscular dystrophies span a very wide range of severity. If we then think about how this applies to the dystroglycanopathies shown in the lower half of the slide, the congenital muscular dystrophies associated with the dystroglycanopathies carry some names with them, and these are historical names. Walker-Warburg syndrome is the most severe, and that involves very severe malformations of the brain, eye, and muscle. Muscle, eye, and brain disease and Fukuyama muscular dystrophy are sort of intermediate. They do involve abnormalities of the eye and brain as well as muscular dystrophy, but less severe abnormalities. And then other named forms, letter and number named forms of congenital muscular dystrophy are more mild and may or may not involve the brain and eye. And then the Dystroglycanopathies also include the limb-girdle muscular dystrophies with a very wide range of presentation. So that's where this mini lecture ends, and this is an introduction to what the Dystroglycanopathies are. And in the next mini lecture, we will go through a series of cases and see if we can, what we learn from each of these cases about the clinical presentations and manifestations of the Dystroglycanopathies.